Hello, welcome to the video. In this section, we're looking at 2.5, where we are proving statements about segments and angles. So the thing that we're going to be the question that we're going to be asked to answer is how can you prove a mathematical statement? The way that you prove a mathematical statement is through basically through the deductive reasoning method, being able to use definitions, accepted practices, theorems, postulates, all those things that are going to assist us in being able to prove from what they give us to what they want us to prove. And we're going to look at, different examples to show um, how we can prove those things. It takes a lot of steps. It takes practice. So, um, so yeah. So let's get into it. So the first thing that we're going to look at is this. We talked about this in the previous section. We talked about a two-column proof where we had the statements on the left and the reasons on the right. So the statements are, in this case, are the step-by-step ways of showing how we take what we were given and then use those givens to prove that something is in fact um, to prove exactly what they're telling us to prove. So in this particular one, they're giving us that AC is equal to AB plus AB. All right, so that's given. All right, this one here, they gave us all the statements. We have to figure out the reasons and why how we were able to come up with that. So for the first thing here we have, it says that AB plus BC is equal to AC. We can make that conclusion because of the segment addition postulate. Okay, so segment addition postulate allows us to make that claim. Then from here, it went from AB plus AB is equal to AB plus BC. So this is basically we're just um, using the transitive property. Because if you look, they have a common value of AC in that it's equal to, so then transitive property states that then these two are equal. That's how we were able to write that third statement. And then finally, they have here AB is equal to BC. The reason why we can say that is because you can subtract an AB from both sides, which then makes this cancel. So the subtraction property of equality is the reason we were able to do that. That's the proof. We're done. All right. Some proofs take, you know, 3 or 4 steps. Some take 5 or 6. Sometimes they take more. But uh, a lot of it is just being able to decode what they gave us and help us figure out what we needed to prove. Now, in this particular one, they gave us all the reasons, and now we have to kind of fill in some of the statements. Okay, so this is, again, kind of, introducing us into proofs where I understand that it can be kind of daunting and complex, but hopefully with practice, you will get better and better at it. So the first statement they're telling you is given. So the given statement's right here, so I can easily write the measurement of angle 1 is equal to the measurement of angle 3. All right. All right. They gave that to us, but also the hash marks on the diagram itself tells us that they are equal as well. So here, the next step from there, it says that the measurement of angle EBA is measurement of 2 plus measurement angle 3, angle addition postulate. That makes sense. EBA is now equal to measurement of 2 plus measurement angle 1. So they just substituted because, well, we know that 1 and 3 are equal, so we just substituted those two values in. That's why we were able to give that reason. Step 4, it's telling us that EBA is equal to something, and the reason is commutative property. Well, commutative property is you basically flip them, so it's just going to be the measurement of angle 1 plus the measurement of angle 2. Because commutative property means you can just flip them around and they're still going to be equal to the, same thing. So what we now can say is the measurement of angle 1 plus the measurement of angle 2 is going to be equal to, well, if you notice, that is angle CBD, the measurement. I'll put the M there. And then the final step is the proof, the measurement of EBA is equal to the measurement of the angle CBD because of the transitive. Because if you noticed, both these two values here are the same, that means that these two values can be equal. So that's where the transitive property comes into play. So hopefully you guys watched the previous video. So I would say this, to look at that proof, it's going to be the same proof. Just please go back to section 2.4 and that proof will be there for you in its entirety. So, but if you have additional questions, please let me know. What we have here is basically just a series of um, properties of segment congruencies and properties of angle congruencies. And we kind of touched on them a little bit when we talked about reflexive, symmetric, and transitive. And they're pretty straightforward. You can find them on page 101 in your text if you don't want to write them out. So they are there in those pages. And again, we kind of touched those on in an earlier section. So here they're asking us to name the property that the statement illustrates. For part A, it says if angle 1 is congruent to angle V and angle V is congruent to angle R, then T equals R. So if you notice that they both share angle V, so that means that these two can be equal to, that is transitive. And then here it says JL is congruent to YZ and YZ is congruent to JL. They're just flipped around. So in order for that to be true, that's symmetric. All right, I believe this is the last. We got a couple more. All right, so here we want us to write a two-column proof for the symmetric property of segment congruency. So basically what they're doing is they want you to take LM is congruent to NP and they just want you to flip it around. They want you to prove that. So here we make our statements and our reasons. So first we write what's given. LM is congruent to NP, and that's given. All right. So for some reason, I'm not exactly sure what they want you to do here is they want you to convert um, these line segments to be congruent to be equal. So what you're basically going to do now is you're just going to write in the same thing, except instead of being congruent, they're going to be equal. And your reasoning for that is the definition of congruent segments. Because if they're congruent, they are equal. All right. Then from there, you are then to take and flip them around and say NP is equal to LM because of the symmetric property. And then finally resort back to congruent and say definition of congruent segments. I'll be honest with you, I believe if you just went from step 1 and then step 2, just flipped them and said there was symmetric property, I think that would be good enough. But um, this is another way of looking at it for sure. All right, so here it says prove this property of midpoints. If you know what that M is the midpoint of AB, prove that AB is 2 times AM and AM is 1/2 AB. So they're looking for two things for the proof. So they're telling you that M is the midpoint of AB. All right, so that is a given. So when we write our statements and our reasons, so the first thing we can say is M is midpoint of AB, given. The second thing we can now do is we can say if that's a midpoint, then these two side measurements are congruent. So I can say that AM is congruent to MB, and that would be from the definition of midpoint. Part 3 is basically we kind of do what we did before, is now converted to equals. So AM is equal to MB, and just like the previous reason, definition of congruent segments. Then what we can do is kind of look at the algebra sense of this for step 4 is, well, we also know that AM plus MB is going to be equal to AB, and that comes from the segment addition postulate. All right, so how is this going to help us? Well, we know that AM and AB are going to be equal to each other, so I'm going to choose one of the two to be equal. So since they're dealing with um, since we're dealing with AM here, I'm going to put both of them as AM. So step 5, it's going to be AM plus AM is equal to AB. And I'm able to do that because I can just substitute it in because they're equal. Substitution property. And part 6 here is, since I have AM plus AM, those are like variables, so now I can say this is 2AM is equal to AB. Well, that's what we have right here. And in the book, they said distributive property, but you could also put like terms, I would say. And then the next thing they want you to do is AM is half of AB, so that would just be dividing 2 to both sides, so it'd be division property. And that's both our proofs. So 6 and 7 did both of those proofs here and here. Okay, like I said, it takes practice. Um, we'll get through it. I understand it's not the most fun thing in mathematics, but it does have to be done. Okay. Here is just they talk about it. Just this is just a summary of writing 2-column proofs. Some of the things just to take from it. Statements are based on the facts that you know or the conclusions from deductive reasoning, which we talked about at the beginning of the notes. And the reasonings comes from definitions, postulates, proven theorems that allow you to state from the corresponding statement. And again, the number of statements will vary. So please keep that in mind. And that is being able to prove statements about segments and angles. Hope this helps. Till next time.